So continuing where we left off earlier in the lecture, I think it's best to sort of view these things as involving a constant evolution between people building systems and between would-be hackers. Okay, it's not just the case you can build one completely invulnerable system and that's it. And indeed, it might be best to think of this as an ongoing technological arms race. So currently, conventional financial systems and blockchains such as Bitcoin and Ether rely on something called elliptic curve cryptography. So Ether is the blockchain which underpins the second most highly capitalized cryptocurrency, Ethereum, and this Bitcoin and conventional finance all rely on something called elliptic curve cryptography. So in theory, it might take many decades to crack 256-bit elliptic curve cryptography using conventional computers. However, it's believed that once quantum computers become commercially available and available in number, they will be able to break these encryption systems. So there's thus a need to develop progressively stronger encryption in tandem with other computational advancements. And again, I think it's best to think of these things as involving constant co-evolution between people building systems and would-be hackers. It's not just the case that you can build one completely invulnerable system and that's it. So I'm always a little bit concerned about excessive hype, and I'm concerned here about becoming or seeming to be too much of an enthusiast for Bitcoin and blockchain. Neither Bitcoin or blockchain are yet a religion, but the serious point I wanted to mention here is this sort of evolutionary angle. So what you have is a process called forking, where you can have new coins evolving from old coins. This is discussed in Shria 2020, and the analogy is a little bit like how Christianity branched off from Judaism. Okay, but the basic idea was, due to the intense pressures involved in the sort of very harsh evolutionary landscape, a second variant of the basic Bitcoin protocol, Bitcoin Cash, was developed, which is thought to have certain advantages, notably speed. Okay, so this is intended here just to emphasize this process of co-evolution between people building systems and would-be hackers that occurs all the time. And as part of this process of co-evolution, what you have here is a new variant of the Bitcoin protocol, Bitcoin Cash, that is evolved out of a process of forking. And the very fact that this term has a name does, I think, further illustrate that there is a clear evolutionary angle to how these things develop. So the fact that this process of forking has a name does, I think, emphasize that improvements to blockchain can be made all the time through this process of evolution. So, for example, Ether is a new type of blockchain originally launched in 2013. So the way this works is potentially a little bit confusing. So usually call it Ethereum because that matches the name of the cryptocurrency, but the basic blockchain is probably best referred to by the name Ether. So this Ether blockchain is designed to be easier to program and to be more flexible than blockchain, or than the Bitcoin version of the blockchain at least, while sharing the same basic characteristics like mining and blocks. So the main innovation of Ether is to try and move away from the idea of blockchain just being a device for digital currencies and this introduction of smart contracts. So other improvements to Bitcoin blockchain focus primarily on speed. So things like Lightning and Hedera hashtag, I think it's almost explicit in the names that these things are designed to try and improve the processing speed. Also, this is part of the idea behind Ripple as well. And it's essentially two things going on here: more applications through smart contracts, or just improve speed. So just to re-emphasize then, as part of this evolutionary process of progress and making improvements, there's two main games in town. So the first thing that people have looked at are developing more applications beyond finance and currency, and that's really what's the motivation behind the Ether blockchain, and the Ether blockchain sits behind the Ethereum currency. The second main aim here would be faster processing. So this is the idea behind things like Ripple, Lightning, Hedera hashtag and Bitcoin Cash. So if you think of the sort of level 1 type reasoning, if you just view as blockchain as just a sort of technical gubbins that lies behind digital currencies, and speeding that up is really the sort of level 1 way of developing this thing further, and that's the point of this faster processing. But if you move beyond thinking of blockchain just being something that is used for currencies and look at more applications, and this is something through smart contracts and things like Ether that developments in the blockchain are intended to facilitate. Okay, so the two main things here: more applications beyond currency and faster processing if you really are just going to focus on the currency bit. Now, often when you have a technically demanding subject with a scientific underpinning, as here, the technical names of things are designed to make sense and are done so in a deliberate way. Now, I'm afraid that's true with distributed applications or DApps, but it's less true when it comes to smart contracts. Nonetheless, smart contracts are very important, even if they are slightly misleadingly named. So the key innovation of the Ether blockchain is smart contracts. So the idea is to make blockchain more of a distributed operation system on which you can run different programs or applications. So you're trying to start with the basic Bitcoin blockchain that was designed for a digital currency and use the same fundamental technologies in other applications. So because it is trying to move away from this idea of just being the technical underpinning of digital currencies, in this way the Ethereum blockchain is intended to be genuinely multi-purpose rather than just a currency, and the technical term used for this is distributed applications or DApps. Now the reason for this name, as promised it is deliberately named, is that this means applications distributed across a blockchain network. Okay, so we're moving away now from the idea of blockchain just doing currencies to blockchain doing other things as well. So according to Shreya 2020, smart contracts are misleadingly named. They are not smart and they are not contracts. What they are instead is a set of instructions that execute under certain special circumstances. So if you think of the Bitcoin blockchain as just transferring numerical values between different nodes, if you think in terms of rather of just numerical values, information, then hopefully you can sort of imagine that the same network structure can be applied to other things, not just currencies. Essentially, blockchain is designed to try and ensure trust in an apparently trustless environment. So within this, the Ether blockchain is interesting as it's designed to run different types of computer program on top of a blockchain network. And if you have something like a smart contract, what this is in fact is a set of instructions that execute under certain special circumstances. Okay, and the technical name that does make more sense is these distributed applications or DApps. So literally applications distributed across the blockchain network. So you might have something that is triggered as soon as goods are delivered, for example. Okay, that's what it means by instructions that execute under certain circumstances. So Bitcoin and Ethereum blockchains solve various problems. Okay, but the overarching one that's really important is this notion of creating trust in a trustless environment. The other things that these enable you to do is create an immutable network. Okay, and within that there is an ability to gain access to large amounts of computer power. Okay, you can use that for digital currency, you can just as well use this for a different application. However, these benefits always come at a cost of both speed and scalability. Okay, so in particular, concerns about the processing speed of Bitcoin transactions is just another thing that has to be overcome in relation to it being considered as a genuine practical alternative to regular national currencies. Okay, so this is potentially a big deal and perhaps more subtle than might first seem to be the case, especially if you think about the environmental costs associated with computing power and the electricity generation that is needed in order to power those computers. Okay, so this is potentially quite a big deal environmentally in terms of the amount of computer power required. So as the film line goes, there is a need for speed. Now it is difficult to sort of get your head fully around these figures, but in terms of the relative number of transactions per second, TPS, so MasterCard can handle about 44,000 transactions per second, PayPal about 600, and then Ethereum and Bitcoin are orders of magnitude less than that. So Ethereum can apparently currently handle around 15 transactions per second. Bitcoin, even if it has had adjustments made to it to make it run much faster, can only handle around 7 to 9 transactions per second. So clearly orders of magnitude slower than current widely used systems. In theory, Hedera hashtag, one of the up and coming cryptocurrencies, can theoretically make 250,000 transactions per second. This is beginning to look more practical, okay, but this is yet to be practically realized. In the book by Schreier in 2020, slow Bitcoin processing times are associated with price crashes in December 2017 and January 2018, and at this time it sometimes took 10 minutes and sometimes much longer to clear blocks. So as the film line goes, there is a need, the need for speed, and the new cryptocurrency Lightning is intended to facilitate that. So the name itself is suggestive. It's kind of obvious that if you're going to call the thing Lightning, then one of the things you are going to try and improve is the speed of the process. Here, the speed at which individual transactions can be processed. So the idea is that you essentially subset the original Bitcoin blockchain. So Lightning overlays on the Bitcoin blockchain to create subsets of nodes that talk to each other. So you have subsets of nodes that talk to each other rather than each individual node. And then focusing on these subsets of nodes instead of all the little individual nodes makes the thing much less computationally expensive. This can lead to a measurable increase in the number of transactions per second that the system can process, and the system runs much faster overall. Okay, so note here there is a trade-off. So if you focus instead on subsets of nodes rather than each individual node, you essentially make the network coarser, okay, but at the same time you make the network run faster. So you lose potentially some accuracy because you look at the subset of the nodes, but it runs much faster at the same time. Okay, so another cryptocurrency and network that is intended to increase the speed relative to the Bitcoin blockchain is Ripple, XRP. So the idea is that Ripple takes the fully distributed network of blockchain nodes. These blockchain nodes are then broken up into smaller subtrees. This XRP protocol is then run on each subtree. Each subtree then in turn works on only a subset of the calculations, dramatically improving speed. Okay, so the cryptocurrency is known as Ripple, but XRP actually refers to the underlying blockchain. So note again, if you're focusing on subsets and subtrees of the blockchain network, then you're introducing a coarser structure. Okay, so necessarily you're asking the computer to do less, so things run more quickly. However, there is potentially a loss of information. Okay, so there is always, with this idea of a blockchain, a trade-off to be made between achieving consensus and the amount of computational work you're prepared to fund in order to achieve consensus. Okay, now this isn't just an abstract thing. Computational speed can have important environmental implications.